Hello everyone. Today I will be going over a price discrimination constraint slash monopoly problem because I feel as if though it is important and it could get tricky at times, especially when solving for the constraint. So let's get right into the problem. The problem states, suppose a textbook monopoly can produce any level of output it wishes at a constant, marginal, and average cost of $5 per book. Assume that the monopoly sells its books in two different markets that are separated by some distance. The demand curve in the first market is given by Q1 is equal to 55 minus P1, and the curve in the second market is given by Q2 is equal to 70 minus 2P2. We're going to do question A, or part A first. If the monopolist can maintain the separation between the two markets, what level of output should be produced in each market and what price will prevail in each market? What are total profits in this situation? So the way we're going to go about solving question A is we're going to solve each market individually. And then we'll combine the total profits in both markets to get total profit. But before we do all of that, it's really important that we know that the marginal cost is equal to the average cost, which is equal to 5, which was given to us in the problem. We know the marginal cost is constant, the average cost is constant, it's equal to 5. Okay, now the first step is we have to invert Q1 to solve for P, right? Just meaning that we have to switch the function around so that P is the dependent variable and Q is the independent variable. This is how we'll do it. We'll move P to the left side. We'll get Q1 plus P1 is equal to 55. And then we'll move Q to the other side, and we'll get P1 is equal to 55 minus Q1, and which is equal to P of Q, right? So this is our P of Q function. We just inverted it. Okay. Now, step number 2 is we have to find total revenue. Find total revenue, and the reason we have to do this is because we're going to have to calculate for marginal revenue. So we know that total revenue is just equal to the price per unit, which is P of Q, times how many units you sell. So in our case, we know that P of Q is equal to 55 minus Q1. And we're going to multiply this by Q1 because that's how many units of Q1 we sell. So we know that total revenue is just equal to 55 Q1 minus Q1 squared. Now 3, find marginal revenue, right? We know that marginal revenue is just equal to the derivative of Q with respect to total revenue, which is equal to 55 minus 2Q1, right? We just got rid of this Q1 and we did the power rule here. So this is our marginal revenue. Okay, now number 4. We're going to solve for the optimum output level. And the way we do this is we know that profit max for a monopoly occurs when the marginal revenue is equal to the marginal cost. Well, we know that the marginal revenue, we just calculated it, is 55 minus 2Q1. And we know that the marginal cost is just 5. It's constant. So doing some quick algebra, right? 55 minus 5 is equal to 2Q1. 50 is equal to 2Q1. Q1 star is equal to 25 because we're just going to divide both sides by 2. And Q1 star is equal to 25. Right? Let me actually just show it just so you can see what we're doing. Divide both sides by 2. The 2's cancel out. Q1 is equal to 25. Okay. Now, step 5 is we're going to substitute Q star 1 is equal to 25 into our P of Q function, right? So we know that P of Q is equal, we calculated it, to 55 minus Q1. So P of Q is equal to 25 is equal to 55 minus 25. Therefore, P star is just equal to 30. And I'm just going to make sure I'm correct by pulling up answers. Yes. Okay. Now, step number 6 is we have to find profits. And we know that our profit is just equal to the total revenue minus the total cost, right? We know total revenue is just the price of Q times however many you sell. And we know total cost is just the average cost per unit, so average cost of Q times Q, however many you sell. Well, we know that our optimum price is 30. We know our optimum output is 25. We know our average cost is just 5. And again, our optimum output is 25, right? Doing the calculations, we would get profit is equal to 625. Perfect. And really, that is all we have to do for the first demand function. Now we're going to do the exact same thing for the second demand function. I'm just going to go a little bit quicker. Q2 is equal to 70 minus 2P2, right? We know that 2P2 is going to be equal to 70 minus Q2. We have to divide both sides by 2, divide everything by 2. And we know that P2 is going to be equal to 35 minus Q2 over 2. Again, step 2, find total revenue. We know that total revenue is equal to the price of Q times Q, which in this case is just going to be equal to 35 minus Q2 over 2 times Q, 2, which is just equal to 35 Q2 minus Q2 squared over 2. Okay, good. Step number 3, marginal revenue. We know that marginal revenue is equal to the derivative of Q with respect to total revenue, which is equal to 35 minus Q2. And you may be wondering where we got this Q2 from. We know that the derivative of this is just 2Q2 over 2. We know that the 2's cancel out, and we know we're just going to be left with Q2. So that's where we get this Q2 from. Okay, step number 4, we know we have to do our profit maximization, which occurs at marginal revenue is equal to marginal cost. We know our marginal revenue is 35 minus Q2. We know that our marginal cost is 5. So we know that Q2 is equal to 35 minus 5, which is equal to 30. So our Q2 star is equal to 30. Now to solve for price, we're going to do sub Q star 2 equals 30 into price of Q, right? We know that our P of Q for this one is 35 minus Q2 over 2, right? So we know that P of Q is equal to 35 minus Q2 over 2, right? So we know P of Q equals 30 is going to be equal to 35 minus 30 over 2, which is equal to 35 minus 15, which is equal to 20. So we know that P star 2 is equal to 20. Again, number 6, find profits for the second demand curve. So we know the profits is going to be equal to our price, which is 20, times however many we supply, which is 30, minus our average cost, which is 5 per unit, times however many units we produce, which is just going to be equal to 450, right? And we know that let me just write a star, our profit total is just going to be equal to 625 plus 450, which is going to be equal to 1,075. Perfect. Oh, sorry. Perfect. And then finally, we're going to do a little proof here. We know that the price of 1 is greater than the price of 2 because the elasticity of 1 is less than the elasticity of 2, right? And we'll prove this. We know that the elasticity of 1 is equal to the derivative of Q with respect to P of Q times P star over Q star. Let me just make sure I'm getting that right. Which we know that in our first demand function, or first P function, P1 is equal to 55 minus Q1. So we know that this derivative is just equal to -1 times our P star, which is 30, over Q star, which is 25. Times 30 over 25, which is equal to 6 over 5. So E1 is equal to 6 over 5. We know that E2 is equal to, it's the same thing, but for the second demand function. So we have to find the derivative of this, which is just negative 1 over 2. Sorry. The derivative of this is, yes, negative 1 over 2. Equal to negative 1 over 2 times 2 over 3, which is just equal to 2 over 6, which is not what I got. Sorry, so something is wrong. Oh, sorry. I know what's wrong. It's not P of Q. It is the derivative of Q1, like demanded, over price. Sorry. Big mistake. So we know that, we know that this derivative here, dQ1 demanded over the derivative of price, which is this, is -1. We know that this is going to be equal to the derivative of quantity demanded 2 over the derivative of price times P star over Q star, right, which is equal to, we know that this derivative is -2, right, 70 minus 2P2, we know it's -2, times, again, what was it, 20 over 30? 20 over 30, which is just equal to 4 over 3. And we know that if we did our calculations, 4 over 3 is bigger than 6 over 5. So therefore, we can confidently say that the price of 1 is greater than the price of 2 because the elasticity of 1 is less than the elasticity of 2. Perfect. That is A complete. And that was the easy part, to say the least. Let's also do one more thing, actually. We know that P star 1 is equal to 30. We know that P star 2 is equal to 20. So therefore, we can say that P star 1 minus P star 2 is equal to 30 minus 20, which is equal to 10. Which we're going to need to know for the next question, for part B. Okay, let's go to part B. Part B says, how would your answer change if it only cost demanders $5 to mail books between the two markets? What would be the monopolist's new profit level in this situation? What that essentially means is when it says it only costs demanders $5 to mail books between the two markets, that means it's now cheaper for consumers to mail books between the two markets. And because it's cheaper for consumers to mail between each market, it should intuitionally, like your intuition should say that the monopolist loses power if it's cheaper for consumers to mail between the two markets. And what that should tell you is that the profit should decrease. which it does, but we're just going to prove it now. And it could be long. Like, it is a long solution. I'll tell you that. So we know that now that P star 1 minus P star 2 is equal to 5. It's no longer equal to 10 like it was in part A. It's equal to 5. And this is the constrained price discrimination. But how do we use this to solve for Q? Well, I'll show you. Step number 1. We know that our P star 1 is equal to, we did this up here, 55 minus Q1. Right? We know that our P star 2 was equal to 35 minus Q2 over 2. Now, if we subtract these two equations, we have P star 1 minus P star 2, right? And we know it's going to be 55 minus 35, which is just equal to 20. Again, let me make sure I'm doing this right. P star 1, so we're going to do minus Q1 minus negative Q2 over 2. So because it's the two minuses, we're actually going to add Q2 over 2, right? And we know this is equal to 5 because we know P star 1 minus P star 2 is equal to 5, and we have P star 1 minus P star 2 here. So we know it's equal to 5. We can then rewrite this as 20 minus Q1 plus Q2 over 2 is equal to 5. We're going to isolate for Q1. Q1 is equal to 20 minus 5 plus Q2 over 2. We're then going to get Q1 is equal to 15 plus Q2 over 2. Right? Let me actually make my highlighter a little bit bigger. Boom. Q1, is equal to 15 plus Q2 over 2. And how do we solve for the optimal amounts of Q1 and Q2? By using this identity. We know that total profit is going to be equal to the price of 1 minus the average cost of 1 times Q1 plus the price of 2 minus the average cost of 2 times Q2, right? Because these are our two markets. Well, we know what P1 and P2 are, and we know what average cost 1 and average cost 2 are, so we can substitute them in. Profit is equal to, we know P1 is equal to 55 minus Q1 minus our average cost, which is 5, times Q1, plus, well, we know our price of 2 is 35 minus Q2 over 2 times Q2. Now, what we're going to do is we have Q1 is equal to 15 plus Q2 over 2 here. We're going to sub in Q1 into, We're going to sub in Q1 into this big equation. So wherever we see Q1, we're going to replace it with 15 plus Q2 over 2. So let's do it. We know profit is equal to 55 minus, and I'll do this in a different color, 15 plus Q2 over 2 minus 5 times 15 plus Q2 over 2, and then plus 35 minus Q2 over 2 times Q2. And then if we simplify things out, we know profit is going to be equal to 55 minus 15 minus 5 is just going to be 35 plus, minus, I made a mistake, minus Q2 over 2. And the reason is because we have to factor in this negative sign into this whole equation. So this is actually going to be a minus right here. That is my mistake, right? Because we know it's this is equal to negative negative 15 plus Q2 over 2, which is equal to negative 15 minus Q2 over 2. So basically, This is a minus over here. Let me point to it. This is a minus over here, and we're left with 35 minus q2 over 2 times 15 plus q2 over 2. Plus, we can simplify this. 35 q2 minus q2 squared over 2. Perfect. Now, what we're going to do is we're going to take the first order condition of this profit function, and we're going to do derivatives. So we're going to take the derivative of profit, or we're going to take the derivative, of q2 with respect to profit. Okay. We know here we have to do the power rule because we have two functions multiplying each other. And that is basically the derivative of the first one, which is negative 1 over 2, right? Times, it's going to be negative 1 over 2 times 15 plus q2 over 2 plus positive 1 over 2, 35 minus q2 over 2. Sorry, I made one more mistake. I forgot to, I'm going to do this in red because it's a mistake. I forgot to minus the average cost in this function, which is 5. So this is going to be minus 5, and this is going to be 30 instead of 35, right? I put in price 2, which is 35 minus q2 over 2. I forgot to subtract the 5, which is the average cost of 2. So as we're taking the derivative, this changes, plus 30 minus q2, right? Because we know that the derivative of q2 squared over 2 is just q2. Okay, now we're starting to get somewhere. We know that this is going to be equal to negative 15 over 2 minus q2 over 2 plus 35 over 2 minus q2 over 2 plus 30 minus q2, which should equal to 0. All right, so now if we add all the constants, it's going to be negative 15 over 2 plus 35 over 2 plus 30 minus q2 over 2 minus q2 over 2 minus q2 is equal to 0. One more mistake to point out. Sorry, I am off today. These are not q2 over 2, it's q2 over 4, right? 2 times 2 is 4. So sorry for that. There we go. I'm going to pause right here just to make sure you can see it, just so I can lock in for the rest of this question. Okay, beautiful. Now, simplifying, we know that this is just going to be equal to 20 over 2 plus 30 minus 2q2 over 4 minus 4q2 over 4, because we have to make sure it's a common denominator, which is equal to 0. This is equal to 40, right? Minus 6q2 over 4, which is equal to 0. So we know that 40 is equal to, we can simplify this, 2, 3. 40 is equal to 3 over 2q2. And then doing some algebra, we know that it's going to be 80 is equal to 3q2. We know that q2 is going to be equal to 80 over 3. And that is how we solve for q2. Now, I'm going to start on the next page. We know that q2 is equal to 80 over 3. We know that we can sub into p of q2 to find p star 2. So we know that p of q2 is equal to 80 over 3 is equal to, our price of 2 is going to be equal to 35 minus q2 over 2, which is equal to 35 minus 80 over 3 over 2, which is equal to 65 over 3. All right, P star 2 is equal to 65 over 3. Now, we're going to sub Q star 2 equals 80 over 3 into our Q1 equation, which is equal to 15 plus Q2 over 2, which is this equation right here. All right, so we know that Q1 is equal to 15 plus 80 over 3 over 2, which is equal to 85 over 3. And I'm just making sure that I have this right. 85 over 3. And we know that P of Q star 1 equals 85 over 3 is equal to 55 minus 85 over 3, which is simply equal to 80 over 3. So now let's summarize all the information. We know Q star 2 is equal to 80 over 3. P star 2 is equal to 65 over 3. Q star 1 is equal to 85 over 3. And P star 1 is equal to 80 over 3. And we know that average cost 1 is equal to average cost 2, which is equal to 5. Now we can solve for profit. Profit is equal to 80 over 3 times 65 over 3 minus 5 times 80 over 3, right? We know 5 is our average cost, 80 over 3 is the amount we produce, plus 85 over 3 times 80 over 3 minus 5 times 85 over 3. We know that profit is going to be equal to 4,000 over 9 plus 5525 over 9. Just by putting this into our calculator, we know that profit is going to be equal to 1,058.3, right? We know that 1,058.3 is less than 1,075, which was the original profit with no price discrimination constraint. And we can say that a price discrimination constraint which lowers mailing cost leads to lower profits than unconstrained price discrimination. And this just makes sense. The more power the consumer has, the less power the monopoly has, and their profits should decrease. Now, the second part of part B says, what if mailing cost were 0? And intuitively, you should be thinking, well, if mailing cost is equal to 0, then consumers can pick freely between the two markets without having to worry about anything, and therefore the profits should be much lower. So I'm just going to write this here. Mailing cost equal to 0. In order to solve this, we have to find market demand. Right? And this is how we do it. I'm going to go back to the two demand functions. I'm actually going to copy them. I'm going to paste right here. I'm going to cut this. I'm going to cut this. I'm going to go like this. Okay, so we have our two demand functions, right? We know that if the price of we know that if the price is greater than 35, we know that the market demand is only going to be equal to 55 minus P1. We know market demand is going to be equal to Q1, which is equal to 55 minus P1. Well, how do I know that? We just sub 35 in. So if Q1 is equal to 55 minus 35, we know that Q is going to be equal to 20. There is demand in the first market. We know that if in the second market, right, if the price is 35, quantity is going to be equal to 0, right? And for any number above 35, quantity is going to become negative. So therefore, we can say that if the price is greater than 35, the market demand is only consists of the demand of the first market, which is equal to 55 minus P1. Perfect. Now, what happens if the price is lower than 35? Well, if the price is lower than 35, the market demand is both of the individual markets added together. Market demand is equal to the first market plus the second market, which is equal to 55 minus P1 plus 70 minus 2P2. Market demand is equal to 125 minus 3P. And we're gonna get rid of these P1, these little subscripts, because we're looking for market demand. So when the price is less than 35, market demand is equal to 125 minus 3P. Perfect. Now we can invert this to get our P of Q function. So let me do that. Actually, let me choose a different color, right? Hold on, let me choose a different color. We know that 3P is going to be equal to 125 minus QD. We know that P is going to be equal to 125 over 3 minus QD over 3. And yeah. Okay. We have P is equal to 125 over 3 minus QD over 3. I apologize for the cut. I made a pretty big mistake. So I just thought it would be better to refilm this. So we know that our P of Q is equal to 125 over 3 minus QD over 3. We know that our total revenue is equal to 125 over 3 times Q minus Q over 3 times Q. So we know that our total revenue is equal to 125 over 3Q minus Q squared over 3. And therefore, I'm going to go on a separate page. We know that our marginal revenue is equal to 125 over 3 minus 2Q over 3. Okay, now we can do our profit maximization, which we know occurs at marginal revenue is equal to marginal cost. We will get 125 over 3 minus 2Q over 3 is equal to 5. 125 over 3 minus 5 is equal to 2Q over 3. 125 over 3 minus 15 over 3 is equal to 2Q over 3. We know that 110 over 3 is equal to 2Q over 3. The 3's cancel out, but I'll cross multiply just to show you why they cancel out. We're going to get 3 times 110 is equal to 2Q times 3. Let me just move this. And then that's how we know the 3's cancel out. So we're going to end up with 110 is equal to 2Q. We know that Q star is going to be equal to 110 over 2, which is equal to 55. So Q star is equal to 55 when the mailing cost is 0. Okay, now we're going to sub Q star is equal to 55 into our market demand, which is this function here, to find P star. So we know of P when Q is equal to 55 is equal to, not this function, this function. Sub Q star is equal to 55 into P of Q. So as you can see with this question, it's really easy to make mistakes that are going to carry over into your whole thing. So no, P of Q is equal to 55 is equal to 125 over 3 minus 55 over 3. We know P star is equal to 70 over 3. Okay, perfect. Now we can find profit. We know profit is going to be equal to 55 times 70 over 3 minus our average cost, which is 5, times our quantity, which is 55, which is equal to 1008.3. And which is lower, 1008.3 is lower than our previous profits of 1058 and our first profit of 1075. So we can say that the lower the mailing cost, the lower the mailing cost, the lower the profit for monopolies, because they lose ability to price discriminate. And that is how you solve this question. So, a relatively short-looking question when you just see it, but it actually takes a lot of time. And as you can see, I made plenty of mistakes. It's very easy to make mistakes. But my recommendation is, if you do see this question on an exam, which is likely if you're given this question to do the steps. Part A is really easy, right? You're just solving for Q star and P star in each individual market. Part B is where it starts to get a little bit tricky, a lot of numbers, easy chance to make a mistake. Same with part C, or I guess part B too, when the mailing costs are 0. It's a tough question, but if you just follow all the steps, you should be fine.